Welcome back to the channel, Makers and Tinkerers. Today we're diving into something that brings your IoT projects to life. Multi-servo motor control using the powerful ESP32 board. Whether you're building a robotic arm, a smart pet feeder, or an interactive art installation, this tutorial is your golden key. The ESP32 isn't just another microcontroller. It's a dual-core, Wi-Fi, and Bluetooth-enabled powerhouse that gives you real-time control and remote connectivity, all packed into a small footprint. So how do you control multiple servo motors with it? The answer lies in using the ESP32's PWM pulse width modulation capabilities. Each servo listens to a unique signal that tells it how far to rotate, and the ESP32 can generate those signals across several GPIO pins, smoothly and simultaneously. Here's a basic code snippet using the Arduino IDE and the ESP32 servo library. It allows you to connect and control up to 16 servo motors without breaking a sweat. Here I am using just two number of servos for demonstration purpose. You can extend this logic to as many servos as your project needs. The ESP32's hardware timers and multiple PWM channels make it ideal for these tasks. Now here's where it gets exciting. Remote control. Since the ESP32 has built-in Wi-Fi, you can easily integrate it with platforms like Blynk, Firebase, or even your custom web server to control your servos from anywhere in the world. Here's what you'll need. One ESP32 development board, two servo motors like SG90 or MG90S, external power supply, optional but recommended for servo stability, a Blynk IoT platform with an account logged in. You can also control the whole project with a smartphone that has the Blynk app installed with the same web-based account logged in to the Blynk app. Each servo will be controlled by a slider on the Blynk app. Slider 1 will control servo 1, and slider 2 will control servo 2. We'll map the slider values from 1 to 179 degrees to match real servo angles. Set up step-by-step procedure for setting up the project. Now let's upload the code using the Arduino IDE. You'll need the ESP32 servo library and the Blynk library for ESP32 installed. I will provide the detailed library versions that will be used in this project. First of all, delete all the Blynk credentials used inside this code, because I have used these for another project. Then search for Blynk in your favorite browser and sign up for an account. I have already logged in so that after signing in, you will see this type of window in your Blynk platform. Then click on Developer Zone and click on the New Template button. Choose Name as Multi-Servo, Hardware as ESP32, Connection Type as Wi-Fi. If you want, then put a description over the box and click on Done. Then choose Data Streams from the left-hand side and click on New Data Stream. Then click on Virtual Pin. After this process, click on Name and edit this place as Servo 1. Choose Pin as V0 and Data Type as Integer. Unit as it is. Change the minimum value to 1 and the maximum value to 179 and click on Create. Click on New Data Stream again and repeat the previous steps, like changing the name to Servo 2, choosing the pin and changing it to V1, the data type to integer, the unit to none, the minimum value to 1, and the maximum value to 179. After that, click on the Create button. In the next step, you got two servos, which are Servo 1 and Servo 2. Then click on the Save button. Then click on the Web Dashboard section and click on the Edit button, which is placed on the upper right section. From the Widget section, bring two slider widgets and drag and drop them on the Web Dashboard area. Then hover over the first slider widget and click on the gear icon. Change the title to Servo 1 and choose the data stream to V0 and click on the Save button. Again, click on the gear icon of the second slider widget, change the title to Servo 2, and choose the data stream to V1. After that, click on the Save button. Again, click on the Save button, which is placed on the upper right-hand side of the Blynk page. You have two slider widgets, one for Servo 1 and one for Servo 2. Upon sliding the mouse, it will increase its value from a minimum of 1 to a maximum of 179. Then click on Devices, which is on the left side of the Blynk page, and click on the New Device button. On the next page, choose the From Template option. Choose the template as the Servo one and click on the Create button. Then you have seen the created credentials for the device in the upper right corner of the page. You need these for connecting the device over the internet for scalability across the globe. Just click on this and it will be copied automatically. Your next step is to open the Arduino IDE and paste the copied code from the beginning of the code. Here in this code, I have created support for 5 servos at a time, but for demonstration purposes, I am using only 2. You can use 7 servos with this board. You have to change the Wi-Fi credentials, such as the Wi-Fi SSID and the Wi-Fi password of yours, so that it will be connected to the internet, and you can use your Blynk platform as well as your mobile device to control those servos worldwide. Here in this code, I am using pin V0 for Servo 1 and pin V1 for Servo 2. If you use 5 servos in your project, then just use pin V2 for Servo 3, pin V3 for Servo 4, and pin V4 for Servo 5. Just to remember that if you use 5 numbers, then you have to declare more data streams like V2, V3, and V4 in your Blynk setup. Attach the servo pins accordingly to the declared pins inside the code. In a servo, there are 3 wires colored as brown, red, and orange. The brown wire is the ground connection, and the red one is VCC, or you may say it is the positive connection. The red wire is mainly connected with the 5-volt external source for better results. But in this board, there are several 5V pins, so that I have to connect directly to the board. And the last one that is orange is for the signal pin. This wire is mainly connected with the declared data stream pins. You have to be very careful while connecting these wires. I am connecting these wires to the 32 number pin of the board. And for the Servo 2 connection, I will simply connect it to pin number 33 of the board as declared in the code. Then simply plug the data cable into the ESP32 board. In Arduino IDE, click on the Tools menu and choose Board as ESP32. I am using ESP32 boards, WROVER model, so I will choose the WROVER model. Again, click on the Tools menu and choose Port. I have COM5, you have different. Choose that particular number. Click on the Upload button in the Arduino IDE. After compiling the sketch, if no error is found inside the code, then it simply uploads the firmware to the board. Have patience. It will take some time for the compiling process. I am fast-forwarding the video. The code has finished the compiling process without any error. It will upload the firmware very soon to the board. Let's wait a little longer. The firmware uploaded successfully. Click on the serial monitor, which is placed upper corner of the IDE below the IDE close button, and select the baud rate as 9600. As we have declared the baud rate as 9600 in our code, Wi-Fi is now connected. It has an IP address, and it will try to connect with Blynk. After successful connection, it will give us the result of a success or failure message. It is now showing the Blynk connection is successful and the ping duration to the Blynk server. Then go to the Blynk web dashboard. It is showing a green indicator with online. From this, we assume that our device is connected to the internet and can be operated from anywhere around the globe. Then simply slide the slider widget. The respective servo will move accordingly. By sliding to a particular number, the respective servo will move to the same angle as the Blynk platform number. You can also use the mobile device to control those servos. Simply logged in with the same account as the Blynk web dashboard, set up the Blynk mobile platform to use the slider widget, and remember to choose V0 for servo 1 and V1 for servo 2. It will operate from a mobile device also. Try it and comment me out. And just like that, you've built your dual servo IoT project using ESP32 and Blynk. It's real-time, wireless, and ready to scale. If this helped you out, show some love by hitting like, subscribing, and dropping a comment with your project ideas. And remember, anyone can write code, but it's what you build with it that makes people feel something. See you in the next video.